I'm honored to have you here, so sit back, relax, and enjoy the show. Thank you for joining us today as we dive into Security Service Telecommunication. Security service is a service provided by a layer of communicating open systems, which ensures adequate security of the systems or of data transfers as defined by ITU-T X Recommendation and ISO 7498 to Information Processing Systems Open Systems Interconnection Basic Reference Model Part 2. Security architecture are technically aligned. This model is widely recognized. A more general definition is in CNSS Instruction No. 4009 dated 26 April 2010 by Committee on National Security Systems of United States of America. A capability that supports one or more of the security requirements: confidentiality, integrity, availability. Examples of security services are key management, access control, and authentication. Another authoritative definition is in Vic Web Service Glossary adopted by NIST SP 895. A processing or communication service that is provided by a system to give a specific kind of protection to resources, where said resources may reside with said system or reside with other systems. For example, an authentication service or a PKI-based document attribution and authentication service. A security service is a superset of AI services. Security services typically implement portions of security policies and are implemented via security mechanisms. Get ready for an exciting exploration as we unravel the mysteries of basic security terminology. Information security and computer security are disciplines that are dealing with the requirements of confidentiality, integrity, availability, the so-called CIA triad of information asset of an organization, company or agency, or the information managed by computers respectively. There are threats that can state attack the resources, information, or devices to manage it, exploiting one or more vulnerabilities. The resources can be protected by one or more countermeasures or security controls. So security services implement part of the countermeasures, trying to achieve the security requirements of an organization. Let's now zoom in on basic OSI terminology and uncover the hidden gems that lie within. In order to let different devices, computers, routers, cellular phones, to communicate data in a standardized way, communication protocols had been defined. The ITU-T organization published a large set of protocols. The general architecture of these protocols is defined in recommendations. The different means, air, cables, and ways protocols and protocol stacks to communicate are called a communication network. Security requirements are applicable to the information sent over the network. The discipline dealing with security over a network is called network security. The X recommendation 1. Provides a general description of security services and related mechanisms, which may be provided by the reference model, and 2. Defines the positions within the reference model where the services and mechanisms may be provided. This recommendation extends the field of application of recommendations to cover secure communications between open systems. According to X recommendation, in the so-called OSI reference model there are 7 layers. Each one is generically called North layer. The entity asks for transmission services to the North entity. At each level, 2 entities and entity interact by means of the N protocol by transmitting protocol data units PDU. Service data unit SDU is a specific unit of data that has been passed down from an OSI layer to a lower layer and has not yet been encapsulated into a PDU by the lower layer. It is a set of data that is sent by a user of the services of a given layer and is transmitted semantically and changed to a peer service user. The PDU at any given layer, layer N, is the SDU of the layer below, layer N1. In effect, the SDU is the payload of a given PDU. That is, the process of changing a SDU to a PDU consists of an encapsulation process performed by the lower layer. All the data contained in the SDU becomes encapsulated within the PDU. The layer N1 adds headers or footers, or both, to the SDU transforming it into a PDU of layer N1. The added headers or footers are part of the process used to make it possible to get data from a source to a destination. With that being said, let's now move on to OSI security services description. The following are considered to be the security services which can be provided optionally within the framework of the OSI reference model. The authentication services require authentication information comprising locally stored information and data that is transferred credentials to facilitate the authentication. Authentication. These services provide for the authentication of a communicating peer entity and a source of data as described below. Peer entity authentication. This service, when provided by the N layer, provides corroboration to the N+1 entity that the peer entity is the claimed N+1 entity. Data origin authentication. This service, when provided by the N layer, provides corroboration to an N+1 entity that the source of the data is the claimed peer N+1 entity. Access control. This service provides protection against unauthorized use of resources accessible via OSI. These may be OSI or non-OSI resources accessed via OSI protocols. This protection service may be applied to various types of access to a resource, e.g., the use of a communications resource, the reading, the writing, or the deletion of an information resource, the execution of a processing resource, or to all accesses to a resource. Data confidentiality. These services provide for the protection of data from unauthorized disclosure as described below. Connection confidentiality. This service provides for the confidentiality of all end-user data on an end connection. Connectionless confidentiality. This service provides for the confidentiality of all end-user data in a single connectionless SDU. Selected field confidentiality. This service provides for the confidentiality of selected fields within the end-user data on an end connection or in a single connectionless SDU. Traffic flow confidentiality. This service provides for the protection of the information which might be derived from observation of traffic flows. Data integrity. These services counter active threats and may take one of the forms described below. Connection integrity with recovery. This service provides for the integrity of all end-user data on an end connection and detects any modification, insertion, deletion, or replay of any data within an entire SDU sequence with recovery attempted. Connection integrity without recovery as for the previous one but with no recovery attempted. Selected field connection integrity. This service provides for the integrity of selected fields within the end-user data of an SDU transferred over a connection and takes the form of determination of whether the selected fields have been modified, inserted, deleted, or replayed. Connectionless integrity. This service, when provided by the N layer, provides integrity assurance to the requesting N+1 entity. This service provides for the integrity of a single connectionless SDU and may take the form of determination of whether a received SDU has been modified. Additionally, a limited form of detection of replay may be provided. Selected field connectionless integrity. This service provides for the integrity of selected fields within a single connectionless SDU and takes the form of determination of whether the selected fields have been modified. Non-repudiation. This service may take one or both of two forms. Non-repudiation with proof of origin. The recipient of data is provided with proof of the origin of data. This will protect against any attempt by the sender to falsely deny sending the data or its contents. Non-repudiation with proof of delivery. The sender of data is provided with proof of delivery of data. This will protect against any subsequent attempt by the recipient to falsely deny receiving the data or its contents. As we enter this new phase, let's navigate the complexities of specific security mechanisms and discover its practical applications. The security services may be provided by means of security mechanism encipherment, digital signature, access control, data integrity, authentication, exchange, traffic padding, routing control, notarization. The tableau shows the relationships between services and mechanisms. Service mechanism encipherment peer entity authentication Y data origin authentication Y access control service connection confidentiality Y connectionless confidentiality Y selective field confidentiality Y traffic flow confidentiality Y connection integrity with recovery Y connection integrity Y out recovery Y selective field connection integrity Y connectionless integrity Y selective field connectionless integrity Y non-repudiation. Origin non-repudiation. Delivery. Illustration of relationship of security services and mechanisms. Some of them can be applied to connection-oriented protocols, other to connectionless protocols, or both. The table X illustrates the relationship of security services and layers. Service Layer 1 Peer Entity Authentication Data Origin Authentication Access Control Service Connection Confidentiality Y Connectionless Confidentiality Selective Field Confidentiality Traffic Flow Confidentiality Y Connection Integrity with Recovery Connection Integrity without Recovery Selective Field Connection Integrity Connectionless Integrity Selective Field Connectionless Integrity Non-Repudiation Origin Non-Repudiation. Delivery. Illustration of the relationship of security services and layers. With that being said, let's now move on to Managed Security Service. Managed Security Service (MSS) are network security services that have been outsourced to a service provider. I hope you learned something new today. Let me know what you found most interesting in the comments below.